So today we will look at the concept of activation energy. What basically activation energy, right? Now, in my video, I said you that enzymes only catalyze those chemical reactions which occur spontaneously in our environment. So enzymes only catalyze the spontaneous reactions, right? Actually, these spontaneous reactions requires activation. These atoms, for example, there are obvious atoms. The reactant is made up of atoms, molecules. These molecules require some activation. They require actually some energy, so they can activate the substrate or the reactant. The substance can activate these atoms or molecules that it can start the chemical reactions. Or you can define this activation energy as energy, say minimum energy required to initiate the chemical reaction or the metabolic reaction, or you can say it is the energy, or you can say it is the energy used to activate the atoms or molecules to start the let me correct the spelling, to start the metabolic. Don't get confused in when I write metabolic and chemical. Or as I said you that chemical reactions that occur in the body are known as metabolic reactions, metabolic activity. Start the metabolic activity, right? So this is the energy. Now let's look at some graph, like what will be the activation energy when in the presence of enzyme, and what will be the activation energy in the absence of the enzyme, right? So here I'm having the graph, basically graph. So I don't think so that you will be able to understand like this. Let us make our own graph. We have space, we can make. Okay, so okay, good. So let me construct. Okay, for example, this is the graph, right? Now consider that we are having substrate over here. This is our substrate. Let me write this thing over here. Substrate. Right? This is our substrate. For example, okay, let me draw a diagram right here. And our product is here. This is our product. Let me write here too. It's our product. It's our product. Now, if for example, okay, for example, in a ordinary chemical reaction where no enzyme is used, what will happen? The substrate, and it will require activation energy. This is the level of activation energy, that how it is. And here this is forming the graph, right? Now what will happen here, basically, okay, let me write here. This is activation energy. This whole graph shows the activation energy. I am having, okay, for example, we are making here, this is the graph of activation energy. This is activation energy, right? This is X. For example, here no enzyme is used, right? No enzyme is used. No enzyme is used over here, right? Now, for example, this is substrate, right? Now, what if we use, for example, if we use enzyme in the reaction, what will be the graph of activation energy when we use enzyme, right? Now, what will happen basically? For example, we use in over here. What will happen? The activation energy will increase, and the product will be formed over here. So this is the energy when. So this is basically the chemical, like this is the activation energy when enzyme is used. As you can see, let me write here. Okay, activation energy when enzyme is used, right? When enzyme is used, you can see the difference over here. Here we were having so much amount of activation energy was used when there was no enzyme, like the heat energy was used in a very high amount. But when you use enzyme, there's a decrease in the activation energy, right? So this is basically work of the enzymes. You can see the product is also made, but with the help of low activation energy, we can make the product more easily. So there's a concept that should I write that over here? That if there is low activation energy is equal to high product speed, right? High product speed. Okay, I think see over here what else is in it. Okay, basically, okay, when this graph reach highest maximum point over here, right? This point is known as transition state. Transition state. What happens over here? Basically, at transition state, products are made, but that are energetically unstable. So it break down. At transition state is a state where it is actually energetically unstable. So basically this is a graph. Okay, so the energy over here, basically, okay, right. Okay, the energy, this one energy, basically, you can see over here, we mark it. Okay, this whole energy is the energy which is lost in the chemical reaction. So this is the energy, basically the energy which is lost during the reaction. Energy which is lost during the reaction, this is that one energy. And there is also a change energy, you can see. Okay, basically this was the energy when this you can observe the change too. There is change in energy too. There is change in energy too. As you can see over when we use enzyme, this is energy, and when we didn't use enzyme, this was the energy, right? So I hope this graph is clear to you, and this is quite important. I hope that I'm successful in explaining you this graph. Okay.